That looks good, eh? Hey, hey.
There you are.
How you doing? Everything's looking good.
Yeah, again, it's just, I think what happens is that there's a blockage because you don't want us to come into the market, they want us to go into them. And then sometimes there is a bit of a blockage.
But your data, your customer data. So we've gone through the whole group. So anybody wants to double check, but like surprisingly, I think it was one of those that didn't need to work with them. Yes. It's of course you think it's ready to do that.
But if you can get stuff,
But yours is, I would say, relative step for your system is feeding these things. So, if you're able to go through right.
yeah.
Okay. Some events during the year for like socializing, everybody's
Yeah.
So if you're the owner, then we will make sure that whatever we will you can see it
It's so funny, there's so many things going on and nobody knows about all this. Yeah. No, that's correct, yeah. But I just think that all of this topics and stuff, everybody's wanting stuff. But I suppose it would just kind of put our heads together and come up with something other than
Some of all the parts.
yeah.
We can also narrow and restrict it because we're doing the even within IoT.
That's exactly
Three guys.
Because
Because I think that's the other problem. You're not signing
to get all the
information, you're signing into my project. We do that.
For this foundation stuff,
It's not overwhelming.
There's a fine balance between that, the size and because sometimes as soon as it gets too big, it's kind of slows down. But sometimes too small and but if I don't get as much traction. So there's that fine mix between speedboat and cruising. You want the speed so that in terms of being able to get fast and stuff, but you also don't want 100 speedboats doing the same thing.
Well, I'm going with that side. Yeah.
Yeah, you just put it up. We've got various websites.
Okay.
So the group
Oh, okay. Excellent. So, you with? Oh, okay, okay.
So we put our paper together.
Oh, I see. Okay. And have you met people to Yusuf Karim? Specialists. And Rama in SA? I didn't know we do all this. I didn't even know that. So, yeah, I bought this in was October in 2013. No. I don't know. I worked a lot with William and Rama. Yeah. So I was there. Yeah, but at that stage, as far as I know, it was very much them driving the stuff, and I don't know anybody else was in the group, right? And then I got pulled back into the core business for a while, and now I'm back at group and doing some innovation stuff. Because of the word innovation, people that are passionate about energy management, for companies, they want to
We want to bring up one of the just right now.
I'm sort of
all of those, then you take your numbers and you apply this to that.
That's the question.
Work out what your
Who
numbers
is he?
Because some of the people, the one that was.
So I mean, the I think it's more. Most
I'm going to try and explain what I do, hopefully. Once I have. I will leave next week the week after, so we'll check after that's when I'm back.
What's another thing?
Thank you, Charity.
Very hard.
Not really.
So we do that, but
Do we have a phone position now? So I have views. Before I began, I was part of the CSR, trying to do the opposite of what we do here, trying to a social movement where people can get kind of stuff. So I came from into this world, so I have my own views in that. But when it's 12, 13, I was trying to debate their own view on mental justice, so they reached out to all the operators, and somehow the male led in my desk, and I figured that's one way everyone was looking, because we ended up on a conference call with them, somebody from the group, and somebody from you, and a whole bunch of people, and myself. Nick was also there with and all five of us had completely staff. I started when we just got into Office 365 and Teams and all that stuff. I started a shared document space, shared group views for positions on matters like this. Because I couldn't find it. And then Strategy was the first one. So I said, guys, before this happens again, let's at least box it out, come together with one view. So it's not embarrassing to be talking about that he does that. At least we like, if it's not with my view, it's fine. As long as we can like, because they're all really fine. I think that's seriously something. Some people are trying to get you, they don't know how to. Have you come right?
sometimes better not to. See, those are the good questions you ask. And also, it's easy that you don't need a program, you do it yourself. That's a good thing. Because you don't write your report and put the date.
Yeah. In the rest of the depending on where you go, right? So it varies from €3, €15, and it is effective to €8.
Oh, you know what they love doing about the Wi-Fi?
Otherwise, you won't.
That you can go down again. You can go down with me. No, 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 no. I've been using that on PS5. But it then picking up 5 minutes. I'm today. Nothing to do with this. You can see that the innovation of my
Okay, I'm complaining about the coffee, you know, and it was
time now.
you know, you've done the whole yeah.
And additionally, if you want to understand what the focus on, that's I'm not going to explain it. So now, here, different from reception, phase 1, phase 2. And we testing out different innovations. Can't keep struggling with stuff.
We like to send you
Okay. Thank you. I have security. So until I asked for appointment, some people so Antonio forwarded to my security. They gave me some what they can't do. I wouldn't know exactly why do I want to tell me. Break my head on this.
You must follow process, my guy. You seem to have forgotten.
Yeah, there's a room for it. There's a place for process. When you're in the core of the business and the process is in line with the core of the business, there's a place for it. But when you're trying to do things differently, you need to do things differently.
That's what I'm struggling with always. When I launch something, I need to
As the donuts have arrived, so that means we're about ready to go. Thanks, man. You killing him.
It's a very high level overview, but we can discuss the details as we move on. Something like this.
But it's the most expensive.
And if I project it from here,
Yeah, I'm just
And they've stopped it
noticing that my
So they've stopped it showing
presentation suddenly is stuck.
protection. So it's glasses for
Don't use the mouse.
Eh?
You want to use it as a mouse?
No, it's just stuck all of a sudden. The entire presentation. Oh, this is working. Oh, there you go. It's weird. I had to do all of that. Where did you send it to me? Just one slide.
yeah,
So I can just copy paste it into my presentation. Eh?
so at the end, you just fix it.
So where did I end off? I ended off there. Paste. In this case, I'll just show it on the desktop. But,
Yeah, no, I mean, it's just, I know, but that's the thing, you know, so it's like, I was feeling so bad for you because he was
will that work? It's all right. Actually, I had this one.
Yeah, that's very similar. Yeah.
The backup. Anyway, how's that? Is that fine?
Yeah.
Yeah, we got him a.
Things moving forward, I hope. I hope. I'm actually going to take this. Can I just bother you? Use things before.
No, it is fine. First, go left.
Thanks, guys. I think we're about ready to kick off. My tiki works. Yeah. You guys will see me there. I think I'll stand here. Good morning. My name is Yusuf. For everyone that doesn't know me, I think 90% of people here are familiar to me, so I guess you all know me. I was in MTN SA up until March for 12 and a half years, part of IT delivery, and I was looking after everything from messaging to portals and apps in the end, and in between some EBU and ICT stuff as well. So I've done a lot of different things at MTN, but my one passion all along has always been innovation, and it's the reason I joined MTN. MTN was always seen as one of the most innovative brands and companies out there, and that's what probably attracted a lot of us in this room to the organization. And while the innovation was always there, what I noticed was that it became a little bit more difficult over time to get involved in the innovation as an individual. You get sucked into the core machine, and as the core machine becomes more efficient at what it does, your opportunities for doing things differently start diminishing. And it's a good thing in a certain way. I mean, the organization starts becoming more focused at what it does and starts delivering what it does in a more efficient way. So where we are now, we can deliver airtime, we can deliver data, we can deliver SMS and bundles like that. Without even thinking, everything's almost completely automated now. It takes a product person a few clicks to configure something on a web page, and we can automate the entire process. But when it comes to something completely different, because we optimize in this one dimension, everything else might take a little bit longer now. And we lose agility like it. Now you can take that same concept and apply it to your own development as well. You can get stuck in an organization doing something and becoming a specialist, and really excelling at it and training your brain around that one particular thing. But what if the world around you changes at some point? How do you adapt? You might be optimizing yourself to deliver something, specialist role, but are you not doing yourself a disservice in terms of your agility and your ability to change yourself over time? So it applies to the individual as the same way it does to the organization. And the organization is only as agile as the individual at the end of the day. Quote I found, and the reason for why my new position exists. When the winds of change blow, some will build walls, and others will build windmills. Right? Our industry is doing well. We're still earning the revenues. We're still making the marks, but it's starting to become a little bit difficult, right? And for some of us that are keeping an eye on what's going on the outside, there might be some big changes coming. And it's important for us to be agile as an organization and to prepare ourselves to be able to build windmills. We still want to be relevant in 2025, 2030. We don't want some small startup to come and disrupt us and we're out of jobs. Some of you might be familiar with the term of exponential. It's a bit of a buzzword at the moment, and a lot of what we're going to be talking about today are big buzzwords. And as you know, buzzwords have something called a buzz life cycle, right? Or hype cycle. They start off with lots of hype, lots of media, everybody getting excited about it. And then people start actually testing these theories out, and it starts dropping, and you get into something called the trough of disillusionment. That's when the reality starts coming through. And lots of technologies go through cycles of this. So if you think of virtual reality, there's lots of hype in the early 2000s. The first glasses started coming out that you hooked up into your PC. But then it didn't really materialize too much. It didn't change the world as it was promised, and it went away for a while. And it resurfaced again in 2005, 2006. Again, some enhancements, and then it disappeared again. And it resurfaced more recently in the last 2 or 3 years as well. And it'll keep doing so because it's what I call an exponential technology. It looks like it's not making an impact. But at some point in time, when somebody finds a really good use case for it, it suddenly disrupts the world. And then everybody notices it. And the people that weren't involved and weren't paying attention get left behind. So on the left-hand side, there are some of the exponential technologies and disruptions which might be coming through in the next couple of years. AI, cybersecurity, decentralized P2P networking, technology-aided learning, global high-speed internet, personal synthetic biology, machine learning, and autonomous vehicles. Now there's lots of these lists. There are some common ones of all of them, and some of them add others. Right? So, for example, this list from Singularity University doesn't have virtual reality there anymore. Some of the others do. Right? But everyone has their opinions. Everyone's keeping an eye on broadly the same ones. What you might not spot there is, or what might be obvious there, is blockchain. Right? And the reason that we're here today is
we're going to start talking a little bit about blockchain, but it is embedded in there, and it's embedded in there in a very interesting way. Who can guess where blockchain sits in that list? Spot on. And decentralized peer-to-peer is where blockchain fits in. It might not be immediately obvious, but hopefully after a few sessions, maybe even today, we'll understand why that's the case. And why that's relevant to us and why we started off with blockchain is that decentralized peer-to-peer networks is one disruptive technology which might directly disrupt the way mobile operators work at traditional telcos. So we all think of blockchain as a disruptor to mobile financial services and banking because of Bitcoin. But what I want to hope to get one message across today, in that just as it might disrupt the banking industry, the fact that it can be used to create these decentralized peer-to-peer networks means that it might disrupt us. And just as the banks are the central authority in a mobile financial system, the telco is the central thing in a centralized mobile network. Decentralization means take us out of the picture, right? So while things like blockchain and decentralization and mobile mesh might be threats to us from the bottom up, there's threats from the top down as well. So that's a SpaceX satellite. Are you guys familiar with SpaceX? That's Elon Musk's plan, not just an experiment anymore. It's a plan in motion already to cover the globe with low Earth orbiting satellites, which will provide, as in the previous slide, global high-speed internet, the other one in this list, meaning one network that covers the entire globe. Right? And he's not the only one. Google was trying to do with Project Loon the same thing. Facebook was going to do it with drones. They've just recently pivoted on that. They've abandoned the drones, but they're going for the same approach as Elon Musk. And there's a bunch of others that are competing for the same space. So this is coming soon. Elon Musk claims that he can probably cover most of the US with something like 848 satellites, and he wants to get the first ones up and going this year already. Just to bring it home a little bit more around where blockchain might disrupt our industry, I want to introduce you to one of many companies that are exploring mobile mesh networks, Wi-Fi networks, that are taking advantage of blockchain. So Amber is a startup company that's got some of the cleverest people in the world working for them, including a lot of South Africans. An ex-colleague of mine from the CSR, Dr. David Johnson, was recently recruited in this company. That's how I came across them. And they're taking one final piece of the puzzle when it comes to Wi-Fi mesh networks. So when I was at the CSR in 2002, we were investigating how we can disrupt the mobile industry by getting communities to build their own networks. And the experiments were pretty good. In Johannesburg, we managed to build a network. We started off at my house across the road at Constantia Kloof, and it spread all the way from my house through Johannesburg all the way to Pretoria at one stage. It was called JWOG, and it hooked up with a similar network in Pretoria called PTA-WOG, and in Cape Town there was another one starting up. Everything was going well with these wireless user groups and these mesh networks, but there was no incentive for anybody to share internet on that network. Not everybody's paying for the individual internet, but we're unwilling to share with everybody else. That's a problem that they aim to solve. So they've created a way to incentivize people to share their internet on top of Wi-Fi networks. So they created these wireless router nodes with built-in blockchain. It's got an ASIC processor, so it does mining right there. And they've created a currency on top of that. So if I want to be part of this network, I buy some of the currency, And it's a way for incentivizing people to share internet on top of that. They've hired Samsung's head of uh, wireless chipsets. They've hired one of the top security guys that were cited in Satoshi's original white paper on blockchain. So they're really going all guns to get this going into market. These are some of the headlines that I picked up yesterday around our industry. If you're not scared enough yet. So in the US and the UK, there's already some massive layoffs of jobs in the telco industry. In India, it's really going hectic at the moment. 90,000 jobs lost this year alone. All these things point to one thing, and that means that our industry is now starting to see the proper pressure from outside.
So you had to put Ericsson.
Hey! I had to put Ericsson in there. But the reason that you're here also, I guess,
I
right?
understand.
So as an industry, we all started to come to this realization. Just as mobile operators are starting to think about how do we make ourselves more agile, our industry partners are doing the same. We're all in the same boat. We all need to think about how we prepare our people to be more agile, and in that way, how we prepare our organization to be more agile.
Just one comment here. I think
Yeah.
you put Wati. I think it's much closer than these numbers show. So I think one of the things you don't have on the slide here is just the amount of consolidation that's happening in African continent. So many people don't see it, and most of MTN don't see it. But some of the supposed big players of the past already exited. Unicom, Airtel is in discussions whether they exit or they merge. And I don't say that to scare MTN, but one of the reasons the pressure is not immediately obvious to MTN is because they're typically the number two market. But the main message, and I agree with you, Sophia, is that the industry has been disrupted because the value of the telephone has changed. And it's real, actually. It's not.
So how many of us are convinced that 5G is the savior and it's going to carry us? Just want to get a feel. Is it? Do you have a sense of comfort that 5G is going to carry us? It's going to live up to its promises? Is there any innovation in our industry?
It's just another technology that's going to enable the OTTs to kill the OPCOs. Because now we're going to make faster, cheaper, whatever. So the likes of your Netflix, Showmax, and everybody are going to be happy, but we are just going to be carrying them.
And
We're not-
commoditized.
And commoditized.
Like
That's all we're
Unesco.
going to end up being.
I think that's my worry, is that we just land up becoming a dump bag and it just gets cheaper and cheaper and cheaper.
And faster and faster
Yeah,
and faster.
and there's some kid in Indonesia sitting in his granny's garage who's going to come up with something that even nullifies this thing and the SIM card that is frankly our only hook right now to the customer. And if some kid creates something that allows you to take the SIM out of the picture, we're dead. And you know, I don't know, I'm showing my age here, but I don't know how many of you guys were at the Global Leadership Gathering in like 2003 when Dr. Michio Kaku spoke. And I never forget his saying, because he said, if you look at Moore's Law, according to Moore's Law, and I'm sure you guys are all familiar with the old Moore's Law story about the doubling of capacity and halving of price and all that kind of stuff, that mobile telco networks will be dead by 2015, he said, according to Moore's Law. That was 2003, and he gave it to 2015. And one of the execs put up his hand and said, and replaced by what? And he said, I can't tell you. I can't tell you what's going to do it, but I can tell you the way, Moore's Law works, that the conventional notion of a telco network as it stands will be dead by then. And so, okay, give him his due. He was maybe out by a year or two or whatever it is, but I think that's the reality. And my worry is that I don't think us as MTN are kind of focusing enough on just like that kind of amber stuff that you spoke about. And I don't know what the answer is, but we just don't seem to be kind of grappling with just the sheer notion that our business could be dead in a year or two, and we're not even seeing it. And we're still thinking that data customers
and voice revenue is our saving grace and the only thing that can keep us going. That's my worry. I don't know.
100%, and that's probably the basis of my hypothesis and why we're here today. Um, so I'm going to get into some of the boring slides.
So Yusuf, I'll just say one thing because I know I'm very passionate.
Yeah, go for it.
So when we sit in the industry, I think your worry has already come to life. And one thing I'd like people to think about in this room is the disruption is because of the behavior, the changing consumer behavior. So we are now in a digital era. So when you think about voice and data, what's happening now is that the typical consumer is no longer thinking of data in the traditional sense. Data has just simply become an enabler of a million experiences. The problem is that those experiences grow every day. Netflix, online banking, Uber, and the consumer's behavior changes every day. It doesn't stop. So every other consumer expects that the data is there to enable experience. So he basically doesn't want to pay for the data. And this is why you start to see trends of data must fall. A typical consumer will wake up in the morning, start using 5 or 6 applications, and then one application freezes, and that's when he realizes, I don't have data. Then what he starts to think is that, crap, I paid 500 Rand, it's ready to finish. What's the cheapest alternative to that? So most of your supposed, and I don't say this to scare you, but most of what you believed were your customers are no longer your customers. They're people with a SIM card just looking for data. And the person who gives them cheaper data, they move there because that person enables their experiences. Now think about that because that's how you behave as well.
Yeah.
You're on WhatsApp, you're on Facebook, you're on Instagram. You don't feel it because you don't pay for data.
Yeah.
You're shielded from it. And what makes it even worse, because unfortunately the MTNs and the Vodacom companies will think that, the high value customers in the urban areas will still monetize them. And that's a flaw because the high value customers have fiber at home, have ADSL. So what they do, what they spend, the experiences they get for 1,000 Rand, if they get out onto your mobile network, that'll only last 30 minutes.
Yeah.
And that's scary, but that's here. So your
And it's now.
is no longer your customer in the traditional sense. In summary, if you're not in the value experience layer, you will be commoditized. It's just a question of is it 6 months, is it 12 months, is it 18 months, is it 2 years?
And don't underestimate the ability for governments to accelerate that. They're all under a lot of pressure to deliver services.
Yes.
And adding to those services now is data and access to data. So what's happening in India is a lot of what's happening in India is a result of the Indian regulators allowing third parties that are more innovative and more nimble to come into the market and disrupt.
And that's a good point because most governments now see telco companies as a restriction or frustration to innovation and growth. So even in South Africa, to make no mistake that these new regulations where they had to move out of bundle prices, the government is feeling pressure from the consumer. But this will accelerate, it won't slow down. So the intrinsic value of data is gonna go exponentially. Now, the typical telecom operator has one model. Sell voice, sell data. Voice is already commoditized, data has become commoditized very quickly. Then think about what that means to your company. It literally means your company will go. But what happens in a telco is that they go defensive. They fight, they what, and then their output start to go down. So what they start to do is they optimize costs, they reduce headcount. Data will grow. The value of data has gone. And to your point, I almost feel that when you look at 5G, 5G might even become a technology that is driven by a government rolling out the network to enable innovation. Now that leaves no role for a telco operator. These are real things, and these are not far.
So I hope everybody's scared enough.
But I mean, so there is opportunity. I think the reason I say this is that I think companies shouldn't look at it from the fact that the industry will die and be commoditized. It will happen. What they need to look at is how do you leverage your resources today in these conversations to create new value?
Yeah, so
because MTN can.
don't build walls, build windmills, right? That's the point. So, I mean, my whole hypothesis and why I need to have a hypothesis in the first place is this is what I'm working on. This is what my new job is at MTN Group. We're part of a innovation strategy, myself, Raman Singh, and Arrow. Our responsibility is to try and stimulate innovation within the entire organization and to try and figure out how we create an MTN which is more agile. My hypothesis on this is that if you individuals are aware of the changes around us and the changes and the impact that those changes might have on yourselves, and start gearing up for the new world, that the organization will go with you. That's the hypothesis. That's why we're here today. Um, so we're putting together this fancy framework with ideas and all this kind of stuff at different stages of innovation. But along each part of this journey, there's certain interventions. And we're trying to map out things that are already running at MTN along this particular journey which we're designing, and seeing how they work together. So in this big picture is a number of initiatives that have started, some which are still going to start, and the one that's important for today, MTN Hackerspace. So MTN Hackerspace is my attempt to get our internal innovation capacity up and going by creating physical spaces like this where knowledge is shared, and specifically knowledge about disruptive technology, right, which might be disrupting our industry that we all need to be aware of. A different view of the same thing, basically, a stage-gated approach to this and where the hackerspace fits in. So it sits between ideation and incubation. I want to use this space to take any ideas which you come up with and give you the opportunity to use the space to implement those. The type of ideas that we're looking for are the ones that also get us to learn about new things. 1 out of 10 is a success in the innovation world. If you get one good idea working in 10, you've done well. But at least if you can learn something out of the other 9, you would have achieved something, right? Even if your project idea doesn't hit the market.
So what's the GTM?
Go to market. Yeah, that's how we take things from MVP, so something which looks like it might work, to mass market. That's go to market.
Just a question. So I used to work in L'Oreal, right? So they had a very binary approach to technology. Because in terms of the beauty industry, they've got a very big chunk of the industry. So their approach was either we invent it or we buy and invest. Do we have a similar approach?
Yeah, so you'll see there's a internal, external focus or split. So while I look after or look specifically at the internal part of innovation, my colleague Arrow looks at the external part. So we've got some investments in late stage startup companies, and we're trying to see if we can move towards early stage funding as well. And I came across L'Oreal in one of those conversations. They fund, I think it's Techstars or one of these accelerator hubs, and we're also looking at maybe working with them potentially there.
Yeah,
so
very aggressive in terms of like that. Yeah, if it's not, if you can't make the best, you just buy it.
Yes, so part of that innovation funnel is deciding whether an idea is something which will work within our core business, or is it better suited outside. That's part of the decision tree that we're going to build into this framework. And sometimes it's on the fence. Sometimes you want to bring in a startup company to work with internal people and get something going, and then you decide whether the go-to-market strategy is internal or it's external. And so this broader framework will try to cover all that kind of stuff. But you'll hear about this later in more detail. For now, I just want to show you where the hackerspace fits into everything. So for those of you that are not familiar with the hackerspace, and there's a lot of people that frown when I say hacking and hackerspace in the company, it's not about security and reaching networks and all that kind of stuff, right? That's partly why I'm struggling to get Wi-Fi in here, because I think I'm trying to hack the whole network. It's nothing to do about that. A hackerspace is a place where people with similar interests, usually in technology, but it's broader than technology really, come together to work on projects and learn together. That's essentially it. So we aim to transform this, what used to be called an innovation lab, into a hackerspace. We're going to create sandbox environments where you can play with different types of technology, where it's easy to get going. You're not going to struggle with corporate firewalls and all that kind of stuff to get to learn what you need to learn. We'll try and open this environment as much as possible. We want to give you exposure to what's happening on the outside as well, bringing some external perspective. I was hoping to have some external perspective today on blockchain, but unfortunately, the speakers had a crisis in family, so that's not going to happen today, but this is the first of a series of events introducing us to blockchain. So we'll certainly have more external people as we go along. I'm going to end off with this slide here. I mean, this is the crux of it all. There's a lot of people in this room, and I've invited specific people here today that are passionate about learning already. People that used to work with me at MTNSA that would spend hours on weekends, at nights, skilling themselves up on technology which they thought were important to themselves and to the company at their own costs often. And it was great. I mean, they really got far. But I think of the potential of those people working together. You know, if you take 3 or 4 people that are interested in the same topic that learn together, I think the opportunities are great. And that's essentially what this is all about. We're going to introduce blockchain in theory, but when I end today, I hope to draw some people that are still interested into working on an actual idea that I have for innovation at MTN, and to use blockchain in that idea and get familiar with the technology, hands-on. So that's the whole concept. How are you guys feeling for the next presentation, which is probably going to be about 20 minutes, half an hour? Do you need a break, or shall we go straight into it?
No, let's do it.
Alan, if I can call you up. Thanks, man. So, Dr. Alan Tongoli is from MTN South Africa, IP Delivery, and he's going to give us a little bit of a high-level introduction into blockchain. Let me get you a slide.
Okay, thank you very much. My name is Alan. I'm going to speak to you about blockchain technology. It's going to be a very high-level overview, and I'm going to speak about this slide. And this slide is going to be a learning opportunity for all of us. We're going to share some ideas together. I'm not Nakamoto, but I'll I'll try all I can to tell you what blockchain is and why we need a blockchain. So for the most part these days, for you to transfer value from yourself to your partners or to your peers, you need an intermediary, such as a bank. Blockchain is a technology that's going to help you to get rid of that intermediary, be able to transfer a thing of value with your peers. I'm not suggesting you get rid of your personal bank yet. We'll get to that stage sometime in the future. So blockchain is a peer-to-peer network, as Yusuf briefly highlighted. It's a peer-to-peer network that uses cryptography to enable parties in that network to share a thing of value. Right. And the way it works is that as a user, as a blockchain user, you submit a request to perform a transaction. And because you're part of the blockchain network, your transaction is submitted to the network. And the transaction that you compose is secured using your cryptographic key. So blockchain is based on public key cryptography. So basically, a pair of keys is generated for you to participate in the blockchain network. A public key, a private key. You can use your private key to sign your transactions and also to secure them. And the other nodes in the network can be able to verify your signatures using your corresponding public key.
So it's a ask questions? Sorry.
Yeah, sure.
Cryptographic key. Is that what you said?
Yeah, yeah.
And who generates the key? How does the key get generated?
So the software can generate a key pair for you.
Okay.
So a private key will be stored locally on your device, and a public key will be shared with the rest of the peers in the network.
So when you create a wallet, Alicia, you've got a wallet, right?
Yes.
Alicia is one of our investors in Bitcoin. So when you created that wallet, some system in the back created a key pair. You were given the private key, and you were allowed to distribute the public key to whoever you wanted. The public key is, if I'm not mistaken, the address that everybody else gets. Right? You were probably instructed at some point, keep that key very safe and don't lose it and don't forget it. Because that key is the only thing which can unlock whatever you sign with that key. And if you lose it, that information is lost. Whatever's been signed with that is lost. And that's the crux of the security in blockchain. You've got the keys.
I hope so.
That's it.
So if you ever use PGP,
Yeah.
right, it's pretty much the same thing, like you should have the key and encrypted and PGP. It's pretty much the same thing. You know what PGP is? It's almost similar to this concept.
Same as SSL, so it's
Yeah. Yeah.
So Tato is our SIM card and security guy from Team Group. So if he's comfortable with the security, then we ought to be. As we go along, if there's any topics that you feel that we need to explore further in a follow-up session, for example, public key cryptography, I'll be happy to pull somebody like Tato along in a follow-up session and say, please help us understand, because I myself also would love to.
Help me find my key.
You joke, but when we built this lab in 2012, we invested in some really nice high-end machines with nice GPUs for the developers. And at the time, Bitcoin had just come out, so the guy said, you know what, things are sitting here, can we just mine? And at the time, you could still mine with the CPU.
Yeah.
So we had these guys mining Bitcoins. I can't find those keys. I don't know where the heck we put them. Yeah, there might be like hundreds of thousands of rand sitting in there. But we formatted them a few times already and all sorts of things. So those keys are probably gone.
So when you submit a transaction to the blockchain network, your transaction needs to be validated. And in blockchain, the validators of transactions submitted to the network, we refer to them as miners. So their work is to validate transactions, and as they do, there is some incentive for them validating the transactions. So,
where does the intrinsic value come from to pay those miners some of the money? Because when I do a transaction with you, I don't pay for that transaction.
Yeah.
But the miner gets paid for validating the transaction. Where does that value come from to pay the miner?
so that capability is built into the network.
Let me take a stab at that. So let's go back to when gold was the currency, right? How did we assign value to gold? What was it that made gold valuable?
Probably the rarity, the scarcity.
That's one part of it. What's the other, how do you get to gold?
But it's also
The effort.
The effort.
Yeah, you have to mine it.
So you've got to put energy into getting gold out of the ground. What Satoshi and the Bitcoin guys have done is said, how do we exchange energy for value, but digitally? So that's where the value comes in. You're exchanging CPU power and electricity and coal power into this token.
But then there's also an agreed level of value when it comes to Bitcoin, right? Which that's becomes like part of getting onto the stock exchange almost, which is what I believe is the value of it. And there's a run on it, and then but now I'm talking specifically Bitcoin and Ethereum and stuff. Then there's an agreed value. And I suppose we could get into the debate around what's the value of a dollar, which is only an agreed value, because technically, since we dropped the gold standard, there isn't really an intrinsic value on the dollar except for what we agreed it is, and that's dictated by markets, who are also just kind of frankly making it up as they go along.
Yeah,
So
it's a consensus amongst
it's
ourselves,
consensus, yeah. So, and that's where your Bitcoin and your Ethereum comes. It's the consensus of what the value
And
is.
also the more demand there
Yeah.
is and the rarer it becomes, the more valuable it becomes.
So I've got a 2-minute clip I'll play after Alan hopefully sum it up as well.
So does it have nothing to do with the miner solving mathematical problems?
Yeah.
That's where the value is.
Yeah, that's where the value is.
That's how you
Because-
get them to consume energy,
Yeah.
by working out a very complicated mathematical problem.
Because as the transactions accumulate, a miner will compile those transactions into a block, and that miner will be required to solve that block. So to solve that block basically means that a miner is given a challenge. They call it mining difficulty. The mining difficulty is actually a hash function. It's a mathematical function, which is computationally intensive. So what a miner has to do, a miner has to calculate what they call a nonce, and that nonce has to satisfy the mining difficulty that's assigned by the network. And when a miner finds the hash value that satisfies the mining difficulty, then that miner is given permission to append its block to the list of blocks that we already have in the network. And after appending that block to the list or that ledger is shared with everybody else in the network.
So just pause there 1 second. Do you all get the concept of a ledger? Okay? So in my mind, a ledger is a record of a transaction, right? And all that your block is the record of the transaction. The chaining part is that things are happening sequentially, one after the other, and what blockchain tries to do is link these things sequentially. So you've got a ledger that's sequentially recorded, essentially.
It's like a different way of looking at a database. So it's a list of transactions in the database.
So you could use a notebook like this as your ledger, and that's what everybody used 100 years ago for ledgers, to record transactions in their business. And the fact that you're going line by line meant that it was sequential. These days, yes, we use databases and we add entries and we put a timestamp in there so we know what happened, the sequence of events in the ledger. But a database you can fool. You can slide in an entry. You can put your own timestamp in there, and this new transaction looks like it happened before the others, right? Blockchain is inherently linear, one transaction after the other, and it's really, really difficult. I won't say impossible, but really difficult to interrupt that linear progression of adding entries in there. Alan will explain why.
Okay. Yeah. So the reason it's difficult is because the blocks that form a blockchain, they are linked to one another using hash values. A block is linked to the previous block by a hash value, and for you to modify that block, you need to recompute the hash values of the previous blocks, and that's a very computationally intensive exercise. It's almost impossible for you to do that. And even if you could try to modify one of the blocks in the blockchain, you still need to share your results with the rest of the nodes. And when the results do not agree, they're going to reject your modifications.
So it's like kind of like you've been assigned this portion of the chain to solve, solve it, you insert it back into the chain.
Yeah.
What you're saying is that if I want to modify that value, there's already millions of transactions that happen.
Yeah.
I need to go back in time, calculate all of them.
All the subsequent ones also.
Okay, that's
And each one of them would have had a miner working at it for hours to get to that point. So if there's 5 after that, you've got to do 5 times the effort to recreate the rest of the chain.
Unless you have a DeLorean and a flux capacitor.
Well, there's another exponential technology which might disrupt this before it even hits the ground, and that's quantum computing. Quantum computing disrupts the entire cryptography world because all this complexity and challenges, and Shweb can attest to this in the back because he loves this topic. You know, becomes a lot easier for computers to solve once you get to quantum computing. Okay, Shweb?
So as miners in a blockchain network, so there'll be several miners, each miner trying to solve a block. The miners have to agree on which block to append to the blockchain. And there's a number of consensus algorithms that miners use to agree. One of them is what they call proof of work. We've just talked about it. You're given a challenge, a computationally intensive challenge. You have to brute force a 32-bit nonce to try to solve that challenge. And then the result you share with the rest of the network. And if the rest of the miners agree to the results you have gotten, then you have proved that you sacrificed computing power to solve the block so that it can be appended to the network.
So does this mean if you are building an application that lives on this ledger, if you create this application in a way that's, let's just say you created it and now you want to change this application, it's going to be nearly impossible to.
Yeah.
So you're going to have a good design methodology for your app.
Yeah.
You're launching.
Yeah, so there's a topic called distributed applications, where one branch of blockchain technology, Ethereum, saw that your ledger entry, the little contract that you're writing down when somebody transacts, might as well be a piece of code, right? And in that way, you have your application, your traditional application, living on thousands of nodes, or the concept of distributed applications. And Ethereum is different from Bitcoin in that you have lots of these people coming up with good applications to put onto the blockchain. And they use this particular method. But what you'll see is a lot of them will start, and then they have to create another one because they change their minds about the application. That is one of the difficulties and the flaws. Because then it takes a lot of work to get the guys that were on the original distributed application to migrate to the new one. And they have to have the guys transfer their accumulated tokens and all that kind of stuff to the new one. It is a challenge.
It seems like what some guys are doing, so that's the real problem. Then they start doing a simple application that looks up entries from other databases, but then it defeats the whole
Correct.
distributed app.
Correct. You break the basis of the security in the ledger.
Okay, and proof of work is mostly used in public blockchains. For private blockchains, some people, for consensus, to grant miners the right to append blocks, they use what we call proof of stake. The larger stake you have in the network, the better chances you have for the block that you solve to be added to the chain.
Sorry, I'll ask many questions.
Yeah, that's the whole point of it, yeah.
Describe the consensus algorithm in more detail. Like, so people come up, they join the network, they announce themselves as nodes. And if people leave, how does that consensus algorithm consider people leaving and joining?
So a requirement is to the requirement is to have a minimum of 2 miners. 2 miners and above should be able to make the system work. Yeah.
And then you need minimum of 51% to agree on something. That's consensus. It's consensus theory, right? There's a lot of theory behind it, but they've applied it to blockchain. And if you have 51% of the nodes in the network, be 2 and above, then you agree that that's a valid transaction. If you have less, then and there's a dispute, then it gets rejected.
It's rejected, you don't retry.
You can retry and try and get consensus again, but you have to retry.
Is it infinite retries, or is it stop at some
Yes, but remember, every time you retry, you're wasting energy as well. So you're trying to hack, you're wasting energy. It's costing you more than it might be worth in the first place.
So when a block has been accepted and a blockchain has been formed, and the ledger has been shared with all the peers in the network, then your transaction is complete. The value that you intended to transfer from one party to another would have been transferred, and it can be used whichever way possible. So basically that's.
So I've got a little bit of a demo here. So this is a little bit technical. It's a sample application that is the simplest blockchain application you can get, written in Go. So Jay, you might like this one. I'm going to restart it here. So can you see it? Yeah. Let me see if I can expand that a bit. So what you're looking at here is the first transaction on a blockchain node, recording a transaction. So the nonce, which Alan was talking about, is essentially almost a random number that gets added to whatever information is being put into the contract. That complies with the minimum set of difficulty rules that are applied. So the blockchain has an agreed set of difficulty levels, in this case difficulty 1, and that means find me a number or a hash number where the first 4 digits are zeros, right? So to find a hash with the first digit being 0 is relatively easy. When you add another 0, it becomes a little more difficult. When you add a third 0, it becomes even more difficult, and it's exponentially getting more difficult as you go along. So your computer sits there and it hashes a random nonce and sees, okay, is this first digit a 0? Yes or no? No, let's try again. And it keeps doing this in a loop until it finds a hash with that satisfies the requirement. Once it's found that, the overall available hashes reduces, and the overall complexity of coming out to the hash increases. I hope you'll be able to see that when I run this demo. Okay. So that's, I'm running the blockchain in the background, and I'm calling this via an API to add something to the block, basically. So that's me adding a transaction. Yeah, it's a glorified code interface. So previously, let me Control plus Z, like you suggested. Is that better?
Yeah.
So that was the original initiating block entry, and then I hit the curl button, and it added another entry into the chain. This new hash function is a combination of the previous information, and that's how the link is formed. So the previous information is encapsulated in the current one. And it's found a nonce. Now usually after you run this a few times, it gets more and more complicated. Now my machine has to actually think about the nuts. So it didn't just quickly come up with the nuts, it had to do some work. So you saw that happening when I with the MGI. And if I do it a few more times, so that was also easy. So it's randomly calculating these hashes until it comes up with one that now meets the requirement. But it's becoming more and more difficult every time I add that. So how I could previously mine on those desktops on the CPU in 2011, can't do that anymore. Now you need a farm of machines and GPUs to be able to calculate hashes. Hey? Yeah, when they start off and the block is small, it's easy, and as you progress, it gets worse.
So, what happens? You're busy trying to solve this transaction. Then another transaction is happening. Does that transaction have to wait for this one to be solved before it can be added on?
I think there is a concept of
yeah, it doesn't have to. It doesn't have to wait. So you can have two miners or more solving a block and finding a solution at the same time. So they call it forking. So it's a fork. You create a fork. So the two blocks or more will be accepted provisionally. And as time goes on, and we get a new block that's solved, if the height of one of the forks gets longer than the rest, so that fork is the one that's accepted as part of the blockchain. So the rest will be dropped.
Okay, so I've got a bit of a 2-minute video clip. We'll have a bit of a break, and then Kagiso will be joining us at, I think it's at 12:30. For those of you that know Kagiso, he's part of the CVM team in MTN Group. But before joining MTN Group, he had a startup company that their solution was based around blockchain. So he's going to take us a little bit further in depth in blockchain and our understanding of blockchain. But first, a little bit of a clip. You can find it. Sorry, I'm still getting used to this Chromecast. Yusuf, you can help me a bit. You're a Chromecast dude, yeah? Okay. Sorry, guys. That's okay. I'm going to do it from my phone. This should work.
I'll take 5-year rat skins and one of those tepid lemonades.
It's one chicken, mate. It's not a chicken.
No, that's much better than a chicken, my friend. That is gold.
What?
Gold. The currency of the future.
Great, come back in the future.
No, Terry, mate, I don't think you understand. This has unlimited use.
Can I eat it?
No.
Can I wear it?
No, you...
Can I use it as firewood?
No.
It's starting to sound pretty limited, mate.
But you can melt it and then turn it into whatever you want.
Can I turn it into food?
No, is this going to take long? Hold your horses, mate. We are dealing in futures here. Ooh, what's that? Is that a rock?
No, worse, it's cold.
Oh, coal. How do I get some coal? Gold. I have people mining for it.
Oh, you have people. La-dee-da. We've got a rich one here, eh? What do you pay them with?
Gold.
Next.
No, they say that this currency could be worth 1,000 rat skins, maybe even more, in just a few years.
Says who?
The people with gold.
Fine. Next.
Every economy ever has been controlled by the big chicken banks. And this is our opportunity to get out from under the big chicken boots, dig up the market, and start taking back our economic independence. Are you with me?
No.
Really? Come on, man. Look, all my mates are doing it.
I'll just get your hand off it, all right? Everyone's trying to predict the next alt rock. First it was stone, then bronze, then iron, now gold. What can I even do with this shiny shit? Make fucking jewelry out of it or something?
Yes, you can do that. Great idea, because it's malleable. And best part of all, there's fuck all of it. It's a finite resource.
Mate, I'll tell you what a finite resource is. My fucking patience right now. Piss off!
You know what? Stuff it. You're taking it back. That's like talking to my dad.
Yeah. Why'd you go discover avocado and smash it on toast, you dickhead?
Yeah, maybe I will.
Sorry, mate.
I'll have a dodo head, thanks.
Half a chicken. Piss on me, not you two.
Oh, no. This is way better than gold. It's silver, or as I like to call it, light gold cash. It's faster to mine. It's...
It's got to be the last one, surely. Ratskins, dodo heads, very tepid lemonade. Get it here.
So Nick, when you were asking those questions, I was picturing you there. Excuse the fish. Sorry about it. Please help yourselves to some coffee while we wait for Kokiso, and then we'll pick it up again afterwards.
I wanted
Yes, please.
we have this is so cool. We need to invite you to the future.
Yeah, I was coming to ask the same thing. Can you add me to your
Yeah. So
guest list?
after this, I'll share some links where we can keep in touch. And
But you can share the slides as well.
yeah, I'll share everything.
And then the other topic I thought maybe if we wanted to make it a bit more mainstream, we could maybe get Manny and the guys, and maybe one week we do a how to use stream Netflix, Roku, crazy. Just kind of mainstream and blow it up a little bit and talk to guys about the LTE network and blah at home and all that kind of shit. And then maybe that becomes an opportunity to just kind of broaden the base. And once we hook the guys in, then we can kind of bring them to something more niche like this.
But, what I wanted to chat to you about was, so we're going to have, I mean, the limited interest in these very niche areas, right? So I can comfortably fit this size group in here. As soon as you talk broader,
we can use the auditorium, or we can use that other space that we've got, because that we can take up to, I think maybe about 80 or 90 in that room.
Unfortunately not, he's in China.
He's the guy everybody's on.
Hardly. He's more in the air than anywhere else.
So that room is going to be built like this.
I saw the plans.
Oh, did you see the
Yeah,
plans
I saw the
about the
plans,
split in four? Did he show it to you?
Shinwai-
Oh, okay.
Shinwai showed it.
Oh, okay. So you know, there's that one that's you're going to be able to have like just a normal session. Then this is almost a Coliseum type environment here with where guys can go around, and then there's a couple of potty things. So we can. So if you want to run a kind of more formal kind of thing, it can happen there. If you want to just do a Coliseum presentation, and if you want to, we can then just put all of that stuff in the corner and just have chairs all over the place and run for 60, 70 people. So I think, I mean, we're onto something now. If you're checking already the interaction and stuff, and I think people crave this because there's a little bit of interaction, Q&A, and there's nothing formal about it, but there's massive learning happening. And we can always then top it up with abstracts, books that we've got in books 24/7 and all that kind of stuff that the guys can read, and we can just send them the links.
Yeah, and the follow-up which I hope happens after this is that we have, if I can get 5 people in this audience.
My bosses might not like it.
No, but you know, your point is so valid. I was just thinking the point I didn't make because I didn't want to belabor the discussion was I was away last week, right? I was in Paris last week. And I can't believe the amount of free Wi-Fi. I mean, you go to the Adidas store, any store is free Wi-Fi. You get on the buses, free Wi-Fi. You get on the train. So you need a mobile network.
No.
I mean,
So I'll give you a small
didn't
example.
use one.
We had our leadership summit.
I was on WhatsApp calling the family all the time on free Wi-Fi.
And that's prediction of what. No, but and that's what people don't realize. You know, before I answer that, we did a study with IGC because our executives wanted to do a study to give Babak a justification to invest in. And IGC came back and they studied South Africa and Nigeria, and basically guys were more or less saying that they look for the Wi-Fi things, hotspots, whatever. They don't pay.
No,
they'll pay for lifestyle indirectly.
Yes, because I mean, I see kids going to sit at the McDonald's because it's free Wi-Fi.
But I'll give an example. I mean, in April we had our leadership summit in Dubai, because now we're Middle East and Africa. And we're with MTN and they were changing our packages or something. So in part of changing our packages, I think some of our profiles, something happened. Basically, so I was offline. The day I arrived in Dubai, I went offline. And I didn't miss the network. I mean, I was hooked on the Wi-Fi the whole time. I could call my wife on WhatsApp. I could do everything else.
Exactly.
Of course, maybe some people couldn't call me.
Yeah, but
my life didn't stop. I didn't even feel it.
Yeah, but that's how I'm saying is that, and I mean, just there's free Wi-Fi.
And Yusuf is making a point. I think what people don't see is that governments are going to figure out now not only how to regulate the cost of some of this infrastructure, but also to build it. So you know, in Rwanda, as a good example, already by 2014, 15, they built a
they want to have a Wi-Fi network.
Yeah, but they did an
Wi-Fi
LTE
everywhere.
network with another supplier, and operators had to share off that network. And of course, those bring the problem is that people are not thinking about it from the consumer perspective. They always when we get comfortable, we think about it.
No, they don't. They don't want to pay. I mean, I always use my little brother as an example when I talk to the guy. This guy's hustling in any way, shape, or form, so he doesn't spend on our network. He used to buy $30 airtime. If he buys $5 now, it's a lot.
And what people don't realize is that the only model, the main model we have, that's probably 19. Mobile money is taking off its own market. It's about 80-90%. Every time the price of data goes down, the value of the company, the intrinsic ability of the company to sustain this,
it's impossible. And they're banking on getting another 100 million customers on it. But the thing is,
so let's speak to
the
Janae, who's
other ideas.
Let's speak to Janae, who's the head of strategy, and he still has a dual data strategy. And I'm like, the only thing, the problem, sorry, I don't know your name, Edgar.
Imran.
The problem, Imran, is that innovating is scary because you have to take risks. And so they don't want to go into
do it. They don't want to take risks because they just want to. They want to build the wall. They're building walls.
No, but it's also because they're selfish. They're thinking, I'm an exec after 3 years. I'm not going to. And it's human nature. But just what I also say, the problem is that what I keep telling people is that they take down thousands of people's jobs. So these sessions are good. I'm so impressed. It's really smart people with ideas. MTN need to understand that the next version of MTN is not a telco company selling data. Otherwise, MTN will not be there. No use of, I mean, I'm not scary. Huh? I can tell you it's scary because most of us in the big companies.
I don't have a card here. I'll bomb you a. Oh, okay.
Well, I didn't manage to just get the messenger thing.
Pleasure, man. No worries. Yeah, that's what I was saying. That's what I was wondering.
Yeah.
I think it's fine. You're up in the world. Just from the pin down.
So all that I will do is I will just show them the thing and then I will initialize the node that I have on Ethereum. And then we'll run just some basic commands on Ethereum just to show them what the node looks like. And I'll show them the blockchain that I have and that's it.
That's perfect. And so we had, I introduced the space market stuff. I didn't do a very high level introduction of blockchain.
You cannot fit it in there.
So let's get to it. Have you got Chrome installed with the Chromecast?
I use Firefox, but I think I've got Chrome installed here. And then do you have Wi-Fi?
Yes, need to get a
So no, it's fine. I think no, I've got onto mine.
But you cast you need to be on this one. It's probably Wi-Fi, so don't worry, it's not blocked or anything like that. ECP running.
This one will just.
This one is fine. The password is ECP running 123. ISI.
Yeah, I've got it.
Just show password. It's still the idea. Take off one again.
Just that stuff went wrong in Nigeria. And the problem is everybody is serious. No, it's nice. So what I'm going to do is I'm going to run parity, and then I'll show the guys the parity node is the Ethereum node. So we'll run basic commands like block size.
We're actually doing a little bit, but we didn't quite say why it's okay.
From
So to cast, just go there. Cast down there.
More two.
There we go. There we go. Choose podium. So this is cast the screen. What do you have to cast your desktop?
Oh, okay.
Your desktop. Say desktop.
And actually,
now your desktop.
If I open Chrome, it will
just display desktop. You want a cookie or you don't need that?
No, I'll be fine. I'll be fine.
Get this guy on?
Yeah, sure. It's how's it going? You know you must keep some secrets, eh? This machine. This machine is the most powerful machine you'll ever meet. This machine.
Yeah? Oh, yeah, I modified it inside.
It's got a turbo.
Oh, yeah, it's all right, like, hey.
And you put rims on the side.
See you guys. See.
Thank you.
Thanks, guys. We're going to kick off with the second part of this session with Lisa.
Okay, I understand you are all blockchain experts. So when I start talking about hard forks and tarmac, you'll understand what I'm talking about, right? One of those is useful, the other one is useless. Okay, so a hard fork is useful, but a tar road is what you drive on. So, but you're experts and you knew that, right? So I just want to find one quick thing here. Cool. So what initially my vision was, I was going to create this beautiful thing wherein we can all send each other messages on the blockchain, my own private blockchain, and you're all going to give me a lot of money and I was going to buy myself a Tesla. We had agreed already, but there was a crisis up north, so we couldn't do it that way. So instead, I'll go around collecting like 10 BTC from each of you, and then I'll still get my Tesla nonetheless. Okay, so my name is Kagiso. I work in the consumer unit. I am a blockchain enthusiast, understand enthusiast, not expert. There's a difference. So enthusiast means I break a lot of things, and I pretend to know a lot of things, but what I know is really, really this little. So I'm gonna show this little with you and share that, but if you want more stuff, go out there and explore and have fun and make lots of mistakes, okay? So what I'm going to show you here, what I've got here, what you're looking at currently is you're looking at my Atom, and that's my blockchain.pi. So what I did is I found something online on how to build your own blockchain. And so I built my own blockchain. So if you were to go through all of that, this is a blockchain. This is effectively what it looks like. And this is the architecture of a blockchain. And you can build your own. So I'm running this one. It runs on my local machine. So if we had done it nicely, you still can connect to my local machine and effectively be part of my blockchain. So the blockchain that I built. It's a very simple blockchain. Its intention is to send messages. So it's a messenger blockchain. You will send a message from party A to party B, and the message will be logged in the log of the blockchain, the same way that any transaction would be, and we'll just inspect the body of how that blockchain looks like.
If I'm part of your blockchain, will everyone see my message?
Everyone, unless it's encrypted. So this one I hadn't done the encryption yet. The next part is to do the encryption. So once it's encrypted, only the person you're sending it to will be able to see it. So that would be like a secondary layer, which is encryption. But right now, what you will see is when we send the message, you'll be able to see the plain text of the message. And the idea is to show you how it looks. But then in the actual chain itself, like if you were to look at the Bitcoin chain or the Ethereum chain, it's actually encrypted and it's hashed. Okay? And then I'll show you that later on. So let's see if I still have the one priority. Okay, so let's see if we can do this. Okay. So all that I'm doing is I am using this to call my blockchain to start. Because it's not in executable or in bash format, I'm actually going to run it from the machine. I think I'm actually supposed to say 3.6, sorry. Python 3.6, because it runs in Python 3.6. But if I don't do that, I'm going to have a problem.
That's why I don't like Python.
Yeah.
Decide which version.
which version you have to do, unless if you reset the core version and then you have to do other magic stuff that I don't want to do. So all that we're going to do is we're going to initialize it and hopefully it runs without a hitch.
Virtual environment.
Cool. So basically all that you're seeing is this indicates that I have the node set up. So when we're talking about an instance that's running on my machine, it's a node. If you're able to connect and run it, you become a second node, and then everybody in the room becomes a node as part of that of the blockchain. So this just shows me that I have a node. The node is running on that particular IP address on the local machine. So what I'm going to do is there's another program. I forgot what it's called, and I installed it the other day. Is it Browserify? Okay, I just need to find one program that I did not anchor to my machine. We're going to use that particular program. I just forgot what it's called.
While Defense is looking at it, what he mentioned earlier is quite important. So after this session, the intention is to use this facility for experimenting, right? For breaking and learning and doing things in a safe environment. I hope to have some of you on board, some of the enthusiasts who want to take this a little bit further. I've got a really good idea on an application which is applicable to MTN that I want to see if we can apply onto blockchain. And we'll do that over many, many weeks and learn as we go along. And we'll use this facility and the tools that I can provide to make it possible. Okay? And hopefully that way we get our hands dirty and understand a little bit deeper the concept of
Postman. Sorry, that's I don't find out.
It with it bronze.
Cool.
I had a few just now.
Okay, so Postman is you can use Postman to basically be able to see. So I want to run an HTTP process, but I don't want to be opening a browser. So what Postman will do is Postman will allow me to run that if I can open it.
So I'm not a fan of all these GUI apps.
Okay.
Yeah, what's nice about Postman is it helps you document your API. So once you've tried something out, maybe it's a code one, you can create the Swagger spec for you and you can share it quite easily out there. Or you can import one and hit it straight away. So it's nice for documenting your APIs.
Cool. There we go. So my Postman is now running, so I don't want to create anything new. I'm going to use an existing one. Okay. So basically, we're going to run on this one. Okay. So what we're going to do now is we're going to run a set of commands. They're standard commands that you will find in any blockchain that you're working on. So you'll have a mining protocol as the normal mining protocol that the miners run on Bitcoin or on Ethereum or Litecoin or whatever you want to mine on. And what the mine does is it basically just solves the prevalent problem and presents the proof of work or the proof of stake, depending on what kind of a chain you're on. So a proof of work is a machine difficult problem, but solvable. So it should take, on Bitcoin, it should take about, it's called Bitcash, is it? Bitcash, I think. But it takes about 15 minutes to solve on average on your higher end pooled kind of resources to solve. And then I think on Ethereum it's much lower than that. It's much lower than that. I think it's under a minute, and then you've got Bitcoin Cash that has got an even shorter time. So effectively the process of mining is, so when a block is produced, when new information goes across, it's carried on a block. In order for that block to be validated, a proof of work needs to be done. So this problem has to be solved, and in solving that problem, you are validating that this block is indeed authentic. You then produce whatever your answer is. So let me give an example. Let's say our proof of work is prime factorization, right? So prime factorization, if you did mathematics, but just for those of you who don't know, is when you take any number
and you write it as a product of its primes. And any number can be factorized as a prime factorization, right? So let's say we take a large number, let's say we take 275,885,000,000 and whatever. It's a really large number, and it take some time to actually prime factorize that number. But to prove that that number is that the prime factorization is correct is easy. You just square and multiply it out, and then you get to the answer. So the answer is easy to validate, but hard to come to. That's your proof of work or proof of stake algorithms. There's very different ones that are going around. But that's effectively what it does. So when you are mining, we are solving that problem to authenticate the transaction that has happened on the node and to make sure that it's not a false, no one is trying to send false information or anything like that. Okay, so that's what miners do. So what I'm going to do now is I'm going to run a basic command. I'm going to do a mine command. So we're going to say mine. Is it a post? No, it's not a post, it's supposed to be a get. Okay, so now, if you look at that, this is the message that comes across, and it's in JSON format. For some tech crazy guys, most of the data you ever want to deal with on the blockchain is going to be in JSON format. It tells me the index of my block. It tells me the previous hash of the block that preceded. This is index 2. The first block that got generated, that's the Genesis 1, that's going to be index 1. So this is only the second block. So if you think about it as a chain, the chain 1, that was the first block. Now my one is index 2, so it's going to go in and sit like that in the ring. So now it's locked in like that. How do I know that it's true? Part of its header or its information that it's pushing, it's telling me the previous hash. So it's telling me that my parent, the block that I am coming after, or the block that preceded me, hashed to this hash, and that's the hash you're looking at there. If the hash was different, it would not reconcile. Okay? Then it's telling me the proof. What was the proof number that had to come up? What is it producing? That proof then goes out to the entire chain to say, hey guys, this is what you evaluated to, and the entire chain can actually say, yes, that's true, or they can reject it. If that number is incorrect, the chain will immediately, this block will immediately be rejected. It won't be accepted by the entire node, and that forms part of the authentication that we're working on. Okay? And then it's got the actual transaction embedded in it. It tells me the amount of money. So let's say, for example, if this was Bitcoin, it means that I received 1 Bitcoin, and then it tells me the message. Now, I added that in. That wasn't in the original scheme of things. So that would be the message that we are transmitting. So if I am sending an I love you to my wife, that's what would be there as a message. But it would be hashed and encrypted so that only she can read it. Okay? And then it tells me the recipient address. This is my address to say this is the person who is receiving the amount, and in that case it would be the end recipient address. And then it's telling me the sender. The sender is 0 because it's a mined. The coin has been mined. Okay. Then, okay, I'm gonna now run transactions new. So what transactions new will do in this particular case is now I'm actually sending that message, the I love you message, okay? So I'm going to,
so just one question.
Go for it, yeah.
You can answer it after if you want also. So for every transaction which happens, for every message that you send, like you can send a message now,
yeah.
Does that result in 2 transactions then? One for validate or mining and one for the message itself?
It's one transaction. All of it is involved.
All in one.
It's one transaction. So when the transaction comes up, it's still going to look the same way. It's going to be one index and the proof. But what's going to happen is that the block itself, the message will not appear to the recipient until the block is sitting on his mind. Which is why Bitcoin transactions take so long. Because it takes 15 minutes, imagine if 1 million people are sending each other money at the same time. They're all on individual different blocks, which means you're having 15 million blocks being produced at an instance, and then the miners are only able to mine after for a period of within 15-minute period, right? So that then makes it very difficult. That's why Bitcoin was not really scalable, and then the guys came up with Ethereum to make it a little bit much faster, and then they came up with Bitcoin Cash to make it even faster than Bitcoin, but not as fast as Ethereum. So they tried a little bit of trying to make sure that at the end of the day, all they were really trying to do was to make the validation occur a lot faster. Okay. So that was all that they were doing. So you're going to have to wait for that. I'm going to do something. I forgot where I put the script for this. And this is going to be a post when it gets.
Ellen, maybe you can help me understand this one thing that I was grappling with. So the miner has to be rewarded. So in a Bitcoin, so this is a message transaction from one person to the other. But in the Bitcoin world, you're transferring value, right? Transferring some Bitcoin from myself to you. And some node out there has got to validate this or do some mining. And he's also going to be rewarded. That rewarding of the miner, that's a transaction in itself. Does that transaction also get added to the blockchain?
The reward of the miner, yeah.
Huh? Is it?
Yeah, the rewarding of the miner.
So there is another.
There's another ledger that's going. There's going to be another entry to say this is the block that this is the pool or the person or the address that mined this one successfully, and then you have to give them. That's a financial transaction. And then there's the actual validation. So there's two. Okay, I understand it now. This is happening. This is where I got the. So you can go to this. I'll share this with Yusuf. This is where I got the source code, and then you can play around with it and change it as you want. It's just one command that I want actually from here.
So what I'm going to do is on Microsoft Teams, I'm going to set up a team for everybody that was here today. I'll be sharing my presentation, this presentation, and any other links, documents, code, whatever it is that we talked about today. But as we progress this Learnathon further, so this is not a once-off, it's going to be continuous. Whatever code we produce, designs, whatever it is, will be added to that repository. Okay?
So I'm going to add one more thing here.
Tell me, does the transaction take place first and then the mining?
Yes.
So what happens is that I'm actually going to buy something that doesn't exist because it has to be mined first.
So you're going to buy something, but we haven't validated when on.
Yeah, but if I'm going to buy, say now I want to buy 10 clams, okay? Where do those 10 clams come from? Some other party's got them, right? Where does he get them from? Yeah, so where is it mined? I mean, when is it actually mined?
So hold on. So in Bitcoin, what you're talking about is transferring value from one person to the other.
Yeah.
So you bought something from me, so you're going to pay me, right?
Yeah.
Okay. You're going to pay me in Bitcoin. Now you've got Bitcoin in the ledger.
Yeah.
The ledger, the blockchain,
All
has a
right, so
record somewhere that says Linton has 100 Bitcoins, and the transaction that we're adding now onto it is you passing 5 Bitcoins to me.
Yeah.
So the fact that you have 100 is already in the ledger.
Yeah.
What we're trying to do next is a transaction where you pass 5 to me and someone's going to validate it.
Yeah.
So it's not like it doesn't exist. The 100 is there. You already have it assigned.
Sure. Okay, so the validation process is basically when you're generating the hash code. Is that what you're saying?
Yeah. Yes. That's the mining, right?
Yeah. So now you generate the hash code while you do that, when you're validating that transaction. In other words, you know the hash code we're talking about over there, right?
But there's different types of validation happening in the same process. One, we've got to validate that you had a balance to in the first place, that you had 100 coins.
All right.
So that's one of the things that has to be validated. And then on top of that, the hashing has to be.
Yeah, you see where the confusion is here. Is how do you differentiate between the asset and the transaction? Because the asset has to be created, right? So if you're creating, from what I'm saying, you create an asset by mining.
We don't know what you bought. We just know what you bought it. We just know about the Bitcoin spinning. We don't know
Sure,
what you bought.
but the basic premise of the blockchain is that you've got an asset, right? And then the asset's being traded between parties, okay? So the asset has to be digital, right? Okay? It can't be, here what we're saying is that you've got to have some plans, okay, recorded somewhere. So that would be a standard ledger. In the case of, so you're not mining, right? Correct.
Well, to start things off, say you like Cookies just created a new blockchain with nothing. I created a new blockchain currency. Let me be more specific. He's going to issue some to somebody to kick things off, so that there is value to trade.
Okay.
So initially, he's going to mine it, or some nodes will mine it, and that's how they'll gain the first set of coins.
Okay.
And then those can be transferred. So whoever's mined it now has something.
Okay, so he's
to
the
trade
owner.
with. Yeah, so it's going to be initiated, if I can call it that. Any currency that you build on the blockchain. So on the Ethereum world, they have the concept of airdrops. So a lot of these guys are creating their own new currencies and things like that. So to stimulate it and to get it going, they use something called an airdrop. So they'll send you an email saying, if you sign up within the next 7 days, you'll be part of our airdrop. And then after that, they give you 50 tokens. Amber, which I showed you earlier, is currently doing an airdrop. So I'll send you guys the link. You can get some free Amber. I've got some out of that process. And the only reason they're doing that is to initiate this transactions, getting people
to squeak the wheels.
Yeah, exactly. Yep.
Okay, cool. Sorry. So basically, we've sent the message. There's the message. I love you. The message is now been sent. And then if we now, so basically this message, well, the I love you message, all that's going to happen is you will be typing it normally on your keypad and everything like that. It will get hashed and it will go that. So now what I actually want to show you is how it looks on the blockchain. So if we go back to the run a get process, and in this case we say block, sorry, chain. Okay, so what you'll notice is this is the length of the chain. You've got index 1, index 2, so this was the Genesis block, and this is that block that I mined. Can you see that my message is not there yet? My message doesn't appear, but I've sent it. So let's see what happens if we run the mine command. So now we mine. So we're going to mine. Okay, there we go. Now my block was mined. To answer your question, now my block was mined. Did you see that when I showed you the entire chain, I love you wasn't there. Now I ran the mine command, and this is the block that was mined, the block that was mined. It's telling me the amount that was, in this case, it would be a guess amount or a transfer amount or whatever it is. And then after that, it tells me the message. That's my message, I love you, the message that I sent. In this case, if it was a private chat, the message would have been hashed, but the hash of the message, or encrypted to sit on the chain. Everyone can see it, but they see it encrypted. They can't read the message unless they know both you and the recipient's, actually your private key, but the recipient's public key they will have. So that will use your either public key cryptography or whatever means of crypto that you want to use to secure it. So you can use whatever the latest one is, but it will be some form of a public key crypto system. Okay?
So
go for it.
Your use case here is a chat app, right?
It's a chat app, yeah.
Built on the blockchain.
Yes.
You've got to have your difficulty very low, because each time you send a message, someone has to mine it.
Yes, 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 yes. So the difficulty will be low. Like for example, the difficulty can be, I don't know what's an easy mathematical algorithm to run, but you can take, for example, if you take a collapsing series. So there's a set of, in number theory, we have a series that you can set up, but the series is self-collapsing. When you look at it, it looks like a long series, but after evaluation, it collapses. It takes about 2 seconds for the computer to evaluate such a series. So if you've got that as a series that you're evaluating, within 2 seconds, it can be mined by the miner at the back end and all of that.
In this example, in this specific example, what is my motivation to mine?
You will receive, here's your motivation. This amount from the mine went to this address. You see this is a different address?
Yeah.
This is the mining address. This is the sender address.
Yes.
You see, so you as the miner, this is what you're going to receive. You're going to receive 1 Bitcoin or one ETH or whatever the currency that we're using in this case.
So I'm literally being paid to chat.
No.
But I'm mining.
No. You as the miner are not the one chatting.
Yeah.
You as the miner are sitting there with your big stack like that.
This
Okay.
is
Yeah.
how I understand it. So you want to send I love you to me.
Yes.
Yeah.
Right?
Yes.
You
Are the miner.
You mined it so that I can get the message.
Yes.
But,
Yes.
but you got paid
All right.
to do
Yes.
it.
So then I rest my case. So what's happening is that every time you send a transaction, you're mining.
Yes.
And that's and that's where the actual value is created.
That's where the value is created back
Okay,
to the
so therefore, whatever transaction you send, it doesn't have to have value because the value will only come afterwards, once it gets validated.
Then it means that it doesn't have to have value being sent across, but I'm going to get charged, right? So right now, let's say you are doing a financial transaction on a normal banking system. You do a wire transfer to me, right? Your bank is going to charge you a transaction fee, right? In the same way, when I'm sending the message, then no, the entire chain charges me an amount, and that's called gas.
So then that's fine, because what we're doing then is we're basically saying that the Bitcoin is one thing totally different to any sort of secured network activity through the blockchain.
Focusing
So-
more on the blockchain technology.
Yeah.
Pardon?
We're focusing more on
We're just using the blockchain
Yes,
technology.
yes, the technology in of itself, right? So this is one block. Remember what the question you asked? There's two transactions, but they're in one block.
It's two encapsulated in one. So
But they're in one. So look at that. So if you look at transactions, that open bracket there, the solid bracket to this solid bracket, it's one. So this is one transaction. So if I was to run a summary and say, give me the result of the transaction, and I was to run the code, this is what I was going to get. I was going to get this transaction.
So let's just say you built this network, and you've only got 3 users on it.
Yeah, you can have as many users as possible. One is the miner, and two are the two people communicating.
So where I'm going with this is, in order for this to work, you need to have a lot of nodes.
Yes, and then that's where the security layer comes in. The more nodes you have, the more you need to, because this is unalterable. And then I'm going to show you what I mean. Now I'm going to show you now what I mean.
And yes, with all this distributed applications and technologies, the power comes in the volumes, the number of
So I mean, you have to have a lot of dudes mining to allow the communication to happen between the individuals.
Yes,
right?
yes.
But the incentive for me to mine, is there? Sorry, I'm just thinking from a customer perspective, right? Is there a risk, hypothetically speaking, that if Zax wants to communicate with you, and there's nobody mining, that the message won't go through?
Yes, there is that risk.
Okay.
Everyone is mining.
All right. So
there has to be miners. There has to be miners. Miners are essential to the entire thing to work. It
Okay.
doesn't work without miners.
So if you remember my example of what the CSR was trying to do with these
the shared network.
networks, there
or the
wasn't
internet.
incentive at the time.
Yeah.
And that's why these things didn't really take off.
But I'm incentivized.
You're incentivized now because you're given some currency.
value,
And literally, from a mining perspective, it's just my electricity because my
Yes.
machine is doing it. It's
Yes,
not like I have to
yes,
be sitting
yes,
there
yes.
tapping away.
Yes,
So it's
yes.
literally
So
just
what you
leaving the
do is
machines
there's a
running.
command there's a command I can run now. If I went to my command line, if I wanted to mine, not that command line, the other
There's
one.
one big problem with this app. If you want to edit your message,
You can't edit it. It's gone. It's gone. It's gone. Yeah. Yeah.
So no nudie pics.
Yeah. Okay. Go for it. Yeah.
And then how would we use this? Would we use our data centers to do our own mining?
We may at the beginning. Normally when they start the community, there'll be like 3-4 guys of us, and then we will start doing both the mining and the communication. Okay, just as an aside, so I'm working to solve that problem. So what I'm trying to do is I'm trying to build a self-mining algorithm that's going to distribute the cost of mining across the entire network, not requiring miners. So everyone who's part of the network will become a miner.
What is subject to your security?
It doesn't do anything.
Yeah, but you've got an application of the user that doesn't want to participate in the network. So you've got to get permission.
So go for it, yeah? Yes. The consensus is built here. So remember that after you've mined, right, you will produce the solution. Look at that one is different, that one there is different, and look at the hashes. Look at this. This one says previous hash was 3A wada. It's giving you whatever the previous hash was. That one there is giving you a different hash of the previous one. So when we hash it, that's how you validate. Because if this gives you this hash, but when the consensus is being built, the hash is different or the solution is different, it gets rejected. the transaction doesn't go through. Money doesn't get transferred, it gets rejected. That's where the consensus comes in. So you have a consensus? No. The miner mines only. Even if it's one miner, they mine.
There's miners and there's validators.
There's validators, yes.
Validators
The block
Where's the
validates.
Okay, so he mines.
Everyone in the node validates. Everybody. The entire network is validated.
I know what the answer is. You know what the answer is. But you're saying
Yes.
That's why it's going to be
He's
easy
mining.
to validate.
It's easy to validate.
It's going to be hard to mine.
Hard to mine, easy to validate.
So if you do this with virtual machines, then you're going to be able to see people's messages.
Like the message will be encrypted. This is just for demo purposes. The messages are encrypted, so the only way you'll be able to read the message is if you know my password.
If you saw my example earlier, it looked pretty much the same, but you couldn't read. It just looked like
So you hashed yours.
Mine was hashed.
Yeah.
So it was, and that's how reality really it normally
This
looks.
doesn't necessarily make sense for chats. If you look at what Twitter's
No, it
doing,
doesn't.
right? They're using Diffie-Hellman in Twitter world.
Mhm.
So it's pretty much the whole thing of shades.
But-
Public keys. And
Yeah.
Diffie-Hellman would be blockchain.
But the thing is that, so in this instance, in this particular use case, I'm using a message there. That can easily be a video. That can easily be a phone call. That can be a secret.
I think his example is just to help us understand
Yes.
how the blockchain
Yes,
works.
yes. So in fact, where I have message, we can change that and say data. Then it can contain any data. Any data. In the case of Ethereum, it has a code, and the code is the contract. And that code is what is executable on condition. That's what's being sent as the data in the message.
Ideal use cases for blockchain is where you want information to live forever. You don't want that thing to ever disappear.
To ever disappear.
You want the proof that is there. That's where it's ideal. Right?
Okay. And then, so if I take you roughly through the entire chain, so this is the whole chain, you can see that you've got the first index, the first block, right? That block got hashed. The hash of that block was now used to form the second block. And then that block got hashed, and the hash of that block was used to create the second hash. So if you want to alter the chain, if you want to alter anything in here, you must alter the first one, the second one, the third one, and. But not only that, you must alter that on every single node at the same time to the nanosecond. That's it. That's wherein it comes in. That it can be done, but it's extremely difficult, and you'd have to be very dedicated and have a quantum computer to be able to do it, or a set of quantum computers to be able to do it. And at this point in time, sorry?
We just have consensus. If you all know the hashing power, if you have to run the hashing power, you're done. You can take whatever you want.
But remember that consensus means more than one, right? So you'll have to have, let's say, you'll have to have a significant proportion of the community on your machine owned by you to be able to have that much sway in changing the block. But remember, you must change history. You must change. You must change everything in the block.
So you must be like 20 minus.
So you must be Watsons, a couple of IBM Watsons together running at quantum speed to be able to achieve that. Okay? So that's basically, so this is ideally how work in a practical sense in terms of a blockchain. Unfortunately, I'm already running late for the Nigeria thing. So if you ever want, or we have more time or whatever, I can take you through that. I wanted to take you through parity. Let me just start it up just for kicks, right? So parity is for Ethereum. So if you have a parity node for Ethereum, it's much faster than the other one. So I'm just going to kick it off. Hopefully it works. So there you can see. So this is parity. That USD amount is the market value of Ethereum at the moment. I think is $414, and that we the gas that tells you the gas price of transaction on the Ethereum network at this point in time. And there you go. Now it's telling me what URL I'm on, and it's starting to sync to the entire node. And that hash, this one here, that gives me the block number, that tells me the number of peers that I'm connected to, how fast I am moving things around, and then it's just going to keep on updating and running. So as transactions happen and they're validated, I'm synced now into the network, I'm validating the node as well. So that's effectively, looked easy when I just ran that command, but that's effectively what it takes to run parity, and I'm on the Ethereum network. I was going to run, a set of commands. My machine is locked. Oh no, it's gone to sleep. Sorry.
Don't stress, Krishna. So what I'm thinking is some of the follow-up sessions that we might want to have is specifically around Ethereum, Parity as a client on that. We can explore the concept of distributed applications on Ethereum and what it means. This is a whole rabbit hole and so on. So this is one place that we can go into.
So could we split it out like hands-on into blockchain, so holding something similar to the chat app, then a distributed app, and then maybe some blocking.
So I'll take whatever ideas you have on how we can, what is the best way forward for this, shall I say, introduction into blockchain, and we can go as far and as wide as we want to. This is a vast space. We've only just touched on proof of work. There's a whole new other world on proof of stake, and there's 4, 5, 6 alternatives to either one of those still, right? And these are public blockchains now. Then there's private blockchains. And I was hoping to have somebody from IBM today talk to us about Hyperledger, Hyperledger Fabric, which are private blockchains, which are specifically more interesting to organizations like MTN that are looking for use cases, because we might not want to put certain type of information on a public blockchain. We might want to have it between entities that we have in control, and that's where things like Hyperledger might be more interesting. So that's another avenue that we're going to explore when we'll be scheduling some follow-ups with some IBM experts on Hyperledger and Hyperledger Fabric. We've got some grads here in the lab that are starting to familiarize themselves with Hyperledger as well. And I think it's a good time now for me to quickly pitch my idea that I want to work on, that hopefully I can get some support from you guys to help me build as well. So the application I thought might be able to benefit from blockchain at MTN is a loyalty program. There's a whole lot of tested use cases out there in the market. I've got some slides and some links that you guys can read if you want on tested and proven use cases. Messaging isn't one of them. You won't find very many good messaging applications yet. But what you will find is loyalty. You'll find currency stuff. You'll find smart contracts. You'll find legal stuff in there, legal use cases. You'll find transport use cases. Lots of those starting to come up. The GSMA is looking at interconnect settlement use cases. Those are all well and good, but loyalty, I've found at least 4 or 5 good startup initiatives that are starting to show some value already in the space. Where loyalty can benefit from blockchain is in linking different loyalty programs together. Right? So this is all about distributed networks and consistency of information and all that kind of stuff. If I took to MTN SA's loyalty program today and I went to eBucks and I said, guys, can't we work together? Let's hook our 2 programs together. It's going to be really, really difficult, technically and legally, to convince them that what we're doing on our side is above board and the way we're calculating points is something they can trust. It's going to be a difficult discussion. Blockchain makes it a little bit easier, the discussion a lot easier. If we say, let's standardize on the same technology.
Thanks very much.
Okay.
Guys, thank you very much. Yeah, so I'm on Teams as well, right?
I'll add you to the Teams as well.
And then so if you post a question on that, and we see is that. So yeah, there's other stuff that I'm working on. So if you want to work with me and have fun when you have time, then we'll work on that. And then I'm also working on this project as well.
Thank you very much. We've got to ping him a lot or extract a lot more from him. And he's only touched on some of the stuff that he's busy working on. But I mean, he had a startup company that was based on some sort of blockchain technology. So we'll certainly try and get more out of Cookie. So the loyalty case is really good. IBM are involved in 2 very big loyalty blockchain applications. One for Citibank in China, and the other one is a startup company called Loyal. And they've applied their Hyperledger technology in both of those use cases. They've also got really good training material on Hyperledger, freely available to us. I'm going to send some links out on that. And they've got made available some sandbox environments on the cloud where we can try out Hyperledger. All the stuff they do is open source, so we've got some of the source code also, and we'll be setting up environments locally where we can play around with those. But most interestingly, there's a loyalty exercise which is available for us to get going. So hopefully in the next couple of weeks, what I want to do is in this lab, 1 hour a week, we'll sit and design a very basic loyalty program and actually start building it. We'll be using things like design thinking to get going, so that we're not only learning about the code that you saw there, but also about the approach, the innovation approach to solving a challenge. So we'll kick it off with a proper design thinking exercise where we consider what the user actually wants from a loyalty program. So it's not going to be purely technical, but for those that are technically minded, we are certainly going to dive into code as well. So whoever's interested in that, I'll be sending out invites after this for a kickoff session. Please join. There's no pressure to deliver. It's an innovation idea. If it becomes a decent loyalty program, all well and good. If it doesn't matter at all. We would have learned something in the exercise, and that's the important thing. Yeah, sure.
So your idea is to combine loyalty programs and then to use your different points. So I can use my MTN points via e-bucks to macros.
So the core problem with all loyalty programs, including our one in SA, is that people don't redeem their points. That's one of the core things.
Yeah, we've actually got
liability.
We go talk to the Vish, they have a big problem because
Finance people hate loyalty programs because you owe people points, meaning there's a liability on your books, and this thing keeps growing.
Yes.
So it looks bad on the books. That's why finance people hate it. But why do you want loyalty programs?
I want to be able to motivate people to use their points. So
Incentivizing behavior, right? That's one of the key objectives. The other one is you want to know your customer. You want to get as much information as you can about your customer, and you want to incentivize them. It's a mechanism for incentivizing your customer to share some of the information. So those are two big problems we have. We don't know our customer, and also we've got the suite of digital services that most of our customers don't know about. We incentivize them to earn points on our core data, SMS, and whatever. And we reward them with the same three, right? And we don't take advantage of the fact that we can use the same program to introduce them to some of our other entities. You know, we could be giving them free Music Plus subscriptions out of their points, or even broader than that, giving them discounts on Travel Start or Zendo, you know, and introducing them to the bigger service offering that MTN has, if we did the loyalty program properly. And that mechanism of going to a Travel Start and saying, can we hook up our loyalty programs, is a lot easier if you go with blockchain.
But wouldn't that mean that MTN and Travel Start are the same blockchain?
Yes, and that's where Hyperledger and Hyperledger Fabric and the private blockchain that's its use case. You create the nodes and you control the nodes. So we, MTN, Travel Start, FNB, whoever it is that joins this this network of loyalty programs controls the nodes.
And I think that's what I see with blockchain, because you don't get the value out of it. It's just one or two parties. You need to have a lot of people.
A standalone loyalty program on blockchain won't make sense.
Exactly.
It doesn't benefit
That's
anything.
my loyalty feels, because if I'm only going to redeem things from MTN, then I'm restricted to MTN.
But I see that's why that's
Yeah.
well, that's what he's saying. Like
It's
today,
something more distributed. Or you need all the parties to agree to be on that network. I need a third party to run that network, because how am I going to trust MTN to run it?
So I want to explore that deeper. I want to explore the problem space of loyalty in one go. I want to explore blockchain as a secondary while we're busy doing that as well. We might come out in a few months' time and decide, you know what, blockchain actually doesn't make sense at all for loyalty. But we would have learned a lot about loyalty and blockchain in the process, which is fine.
It's got a cool idea as well.
Yeah, Nick?
One kudos on blockchain.
That's an awesome idea. We're probably paying a packet for the black, I don't know.
Yeah,
Hey?
yeah, we pay quite a substantial bit to the Canadian guys who run Kudos, and then there's also the actual cost of the redemption of the stuff.
I love it. I mean, it's also a loyalty program. It's a staff incentive loyalty program. We can start there. I love it.
Awesome. The group guys are actually exploring.
Oh, is it?
We might beat them to it. You can just let them know. Cool. Thank you very much, guys. Thanks for coming through. Oh, one more thing before I forget. Blockchain was the first exponential technology that we kicked off this thing with. The next one that there's a lot of interest from different people in is AI and machine learning. So I hope to follow this up with a similar session with AI and machine learning. So if you're interested in that also, just keep out for the next invite. Right? Thank you very much.
Thank you.